In this video, I will discuss about how you can implement a random forest classifier in Python. For this, you would require a Titanic dataset which you can download from Kaggle website. Like the other videos I have in Python, you need to import some libraries, and then you need to read the dataset, training and the testing dataset. You need to clean the data. You need to select some variables, and for the sake of purpose of simplicity and demonstration, I'm just choosing few variables and then choosing x and y, and then fitting a random forest classifier and doing cross validation, checking the cross validation results, and after that fitting the random forest classifier to the training data set, and then predicting for the test data set. This is all what we are going to do. So first of all, you should download the dataset from the Kaggle website. After you have downloaded the Kaggle Titanic dataset, you just import these libraries: NumPy, Pandas, sklearn.ensemble, import random forest classifier. This is required for performing a random forest classification in Python, and cross validation is required for performing cross validation in Python, and matplotlib is required for data visualization. After you have done all these things, you would require to read the data set. Just you have to write pd.read underscore csv, give the path name where you have the training data set. So I have in this path, so train.csv is the file name for the training data set, and the test.csv is the name of the testing data set. Once you have given this training and testing data set, you just have to clean this data. What you can do is, if you want to see that how this training data looks like, you can just write train.head. You can see the first few rows how this it looks like. We want to predict the survival of a certain person in the Titanic, so whether the person was survived or not based on the class of the class in which he was, first class, second class, or third class, and what was the person was a male or a female, and what was the age of the person, and what is the number of siblings he had in the Titanic ship, and then number of parents and children, ticket fare, and cabin name, and embark. So we have these values, and we want to predict the survival, which is survived. It is 0 or 1. 0 means the person was not survived, and 1 means it is survived. So we want to correlate this information of survival of a person with the P class, sex, age, parent children number, and the fare, something like those. So before we begin, we do perform some machine learning random forest classification. We need to clean the data set a little bit. We have some missing values in NaN, and cabin, age, and fare. For a numerical values like age and fare, it makes sense to, for the simplicity, for now we can just impute the missing values in age and fare by the median values. And for the embarked, we can just fill it with the some s or something like that. So now we are filling the age. So train age, we are writing a function data underscore cleaning. We are giving the data frame name, data frame as the input, and we are accessing the age column of that, and we are converting. We are changing the age column and filling it those missing values with the median values of the train of the age variable. Similarly, for the fare, what we are doing is similarly for the fare also we are doing the same thing. So train fare dot fill na train fare dot median. We are again doing the same thing. And for the embarked, what we are filling it with the s, fill na with the s values. And we are imputing law for the sex. Initially we had male and female in the original data, so we will convert when the sex data, when the sex variable is equal to male, we will impute it with 0, otherwise we will impute it 1. Similarly for embarked, we are doing 0, 1, and 2 when the embark is s, when the embark is c, and when the embark is q. So we have done a little bit of cleaning of this data set, and now we are using this function data underscore cleaning, giving the training data set object in the function, and then the testing data set in the this function. And now we have the clean data in the object train and the test. We are choosing some variables like sex, age, siblings, parent, children, and fear for the simplicity purpose. And we have predictor vars now. We just want to have x and y. X is the set of this predictor variables, and then y is the target variable. So we have train and data set, and we are just selecting the predictor vars, and this is the list of these variables. And then we have y as the survived values, which is 0 and 1. So we have now x and y. We can just see the first few 5 rows. We For the x we have sex, age, because we have selected these 5 columns now from the training data set. So first 5 rows looks like this for this x, and for the y we have 0 and 1. So we want to correlate whether the person is survived, that is 1, or whether the person is not survived, that is 0, with these 5 columns with these informations. For in correlating this thing, we are just performing the random forest classifier, and that is so simple. You just have to write the random forest classifier function, give the inputs, some of the inputs. There are a lot of inputs, so you can just see in the sklearn in the website, Python website. And I'm just choosing a simple max depth, which is the depth of the tree, and the tree depth is given as 3. And in this once we have stored this object, a random forest classifier, in model random, we need to give this object in the cross validation. So cross underscore validation dot cross val score. We are using this method of this this class cross validation, and then we are just giving this function inside it, and we are giving the x and y, and we are telling that we need the 5-fold cross validation. So this complete object is being stored into model random CV. We can see what is the model random CV looks like, and then we can see what is the accuracy. So model random CV dot mean, the accuracy of the across the 5 folds of the random forest is 81%, something like that. So if we are sure that the cross validation score is quite good for the accuracy, we can then just write again the same thing like random forest classifier. We have defined this thing with the same parameters, because for the cross validation we have given the same parameters, and this is showing that the accuracy is quite good. So we will again define the same thing, model random forest classifier, max depth is equal to 3, and then we will dot fit function we will use of this object, and this object instance fit to the training dataset at x and y, and then we can just use this object to predict for the test dataset. So model random dot predict function, and for the test, and we are just choosing the predictor vars, because we have chosen only predictor vars for the predictions. So these will be the predictions 0 and 1 for the testing dataset, for which we don't know whether the person is was alive or not, whether the person survived or not. So this is a very basic, and it is an implementation of how you can just implement random forest classifier, how you can perform the cross validation score. Definitely there are a lot of inputs you can give here, which you can see in the help and in the website, but this is just an implementation, so you can get started with this random forest. We need to initialize the model of nearest neighbor. So we have already imported the neighbors. So we will write neighbors.k neighbors classifier. We just give the number of neighbors we want to choose, and we are just giving 4 right now for this starting point, and weights we are using this distance. Then we are just doing the 5-fold cross validation with these model parameters, which is the 4 number of neighbors. For the cross validation, we will use the cross underscore validation dot cross val score. We will give the model name, which is model neighbors, and then give the data x, which is predictor values, and this y, which is the target values. And then the 5-fold cross validation, so we are rewriting CV is equal to 5. So this is the way you are just giving. First thing is to define the model name like this. Second is the writing cross underscore validation dot cross underscore val underscore score, and give the model name x, y, and 5-fold cross validation. After you have done this, you will see that the model label CV, it is saying that 5 folds across the files, 5 folds we have these values of accuracy, and for 5 folds we have these accuracy. We will see that how for which value, like this 2 means when the for the second fold we are seeing that 101, this one has 0.79, this has 0.77, this is 0.71, 0.719, 0.7. These are being plotted, and we are just seeing what is the across the different folds. And then we want to see the what is the average of these accuracy. We see that it is 0.75. It is across 75.6% accurate model for, and we have done the cross validation for the nearest neighbors. You can definitely optimize with the number of neighbors, and you can see that if it changes, but the main objective is to see that how you can just perform. The first thing is to just write this model name like this, and then second is to write the cross validation, and then you can see the average of this, what is the cross validation. So cross validation dot mean, this will be this much. Now once we know that this model is working and this has some good accuracy, you can just start again and write neighbors.k neighbors and neighbors is equal to 5, and then you will fit to the training data set and the y target values. So once the neighbor is once the data is being fitted to this, you can use this object model neighbors to predict. So model neighbors dot predict on the test data, and the test data we will use only the predictor bars, because we have only chosen the predictor bars for fitting this k nearest neighbors. So these are the predictions. Thanks for watching this video. You can subscribe, like and comment if you have any doubts. Thank you.